Since we now know about matrix multiplication, we can talk about the identity matrix and also inverse matrices. They're going to go together here. First of all, the identity matrix is kind of like the number 1. As you know from multiplication, if I do 4 times 1, it's equal to 4. If I do 100 times 1, it's equal to 100. So 1 is the identity, the multiplicative identity, and that's what we're going to be looking at for this identity matrix. It acts like the number 1 when being multiplied by a matrix. First of all, what does it look like? It is a matrix with all 1s down the diagonal, but then all 0s everywhere around it, all surrounding with 0s. This acts as the multiplicative identity for matrices. So if you have an identity matrix multiplied by any matrix, now these are, by the way, square matrices, n by n, meaning that an identity needs to be square. What we look at is any square matrix that we have, this one, 1, 2, 3, 4, if we multiply it by the identity, then what we get is just itself, 1, 2, 3, 4 again. Now the interesting thing about identities is that they do actually go both directions, and so I can do the identity times 1, 2, 3, 4, and also gives me 1, 2, 3, 4. Now we could go into all the details as far as the matrix multiplication, but that's not something we need to do right here. Just know that if you multiply by the identity matrix, as long as they're compatible, what will come out is your original. So here, multiplied by the identity, we get the same thing out. Go in the other order, the same thing applies as well. All right, so that's the identity matrix, and we're going to use that for this next example, particularly in a 2 by 2 matrix. So this is going to help us out with something we have called inverse matrices. Now, inverse matrices, inverses in general are things that sort of undo each other. So we're going to look at the possibility of having a matrix, call it A, multiplied by its inverse. If we have inverses and you multiply them together, what will end up happening is that out will come the identity matrix. So this is going to be a way that we can test to see if matrices are inverses of each other, as if the identity comes out. Now this works the other way as well. A inverse times A, we flip it around. This one will also be the identity matrix, and this is for inverses only. Keep in mind that this -1 here does not mean an exponent. That is, again, a symbol for inverse. So you say this as A inverse, not as an exponent. All right, let's take a look at these. Oh, by the way, if it doesn't have an inverse, which is possible, then a matrix is called singular. We're going to look at calculator stuff in a little bit, but if you see something where it says singular as an error, that just means it doesn't have an inverse. But let's verify that A and B are inverses of each other by multiplying two matrices together. So I'm going to start with A times B in this order. We have to verify both ways, really. So we've got 3, -2, -1, 1 multiplied by this matrix. They're both 2 by 2. And so if we multiply those together, middle numbers match up, outside numbers are 2's, and so what we can expect to see again is a 2 by 2 matrix. So we'll start here, row 1, column 1. 3 times 1 plus -2 times 1. Then row 1, column 2, 3 times 2 plus -2 times 3. All right, down to row 2. Row 2, column 1, -1 times 1 plus 1 times 1. Then we have row 2, column 2, so -1 times 2 plus 1 times 3. All right, now we simplify. 3 minus 2 is 1. 6 minus 6 is 0, negative 1 plus 1 is 0, and negative 2 plus 3 is 1. So what do you know? Comes out as the identity matrix. So that verifies it in one direction. Now I'm going to show you how to use your calculator to do the same thing. We're going to do here instead now b times a. So that's going to be, I'm just going to rewrite them so that we can clearly see the order that we're going in. We're going to go with this one first. I'm going to show you how to do this on your calculator. Now, I still want you to write out in your assignments the details for matrix multiplication, but this is a way that you can check to see what you're doing. So on the calculator, we're going to go to second matrix. And you'll notice I have some stuff in there already. I'm just going to change it, and I'm going to make I'm going to go over to edit, make a 2 by 2 first of all. We have to change the size. So a up here is 3, negative 2, negative 1, 1. All right, then once I have that in there, I'm going to quit out. This calculator automatically saves it. Go back to second matrix. This time I'm going to edit b and put that in as a 2 by 2. And so then it's 1, 2, 1, 3. All right, so once we get those entered in, the calculator is going to do the work for us. We got to quit out though and go back to the matrix menu yet again. So I'm going to do this time b times a in that order. And so I'm going to go back to my matrix menu and grab b first. And then I'm just going to hit the multiply button down here. And then I'm going to go back to matrix and grab the a in this case. So b times a, hit enter, and then what comes out is, nice to know here again, we've got the identity matrix. And so if, like I said, if it works both ways, then we have really verified that these two matrices are inverses of one another. And in future examples, we will look at how to find matrices, or inverses of matrices.